Let's take a look at another functional equation. It says find all values for real parameters alpha for which there exists exactly one function f from real number to real number satisfying f of x squared plus y plus f of y equals f of x quantity squared plus alpha times y. Okay, so actually we consider two cases. The first case will be if alpha equals 0, because if alpha equals 0, it actually vanishing itself. So the original function equation becomes f of x squared plus y plus f of y equals f of x quantity squared. Okay, so we can see the term for the alpha anymore. And in that case, we suppose f of x equals a constant c for all value of x. In such a way, if we plug in this solution candidate into the functional equation, we will see on the left side is actually c, and on the right side is c squared, which means that c equals 0 or 1 for this constant function case. And it means that there is more than one solution. Okay, so we don't really need to care about other cases, but it already violates the condition as this one. Okay, there exists exactly one function, but here we already have more than one function, so we can reject that alpha to be 0. Okay, so for case number 2, so here if alpha is not 0, okay, we can do something else. Okay, so for all z is a real number, we can pick p0 and then z minus f of 0 squared all over alpha. Okay, why it look like that? You quickly see. We would like to prove that f is a surjective function. So we can see that on the left side is f of 0 squared is 0, and then plus actually something. Okay, we don't need to care about what is this stuff, and then equals f of 0 quantity squared, and then plus alpha times y. Y is that expression, which is z minus f of 0 quantity squared over alpha. And as much as alpha is not 0, this value can be defined. Okay, so here we can cancel alpha, and finally this f of 0 squared and f of 0 squared can be cancelled. So it is equal to z. So in that case, for arbitrary z, we can find its original thing such that we can take arbitrary z value. So which means that f is surjective. Okay, so when f is surjective, which means that there exists z is a real number such that f of z is equal to 0. Okay, and here we would like to find what is this value for z. Okay, so let's try to pick p z y. Okay, so we will have f of z squared plus y plus f of y equals f of z squared plus alpha y. Okay, and then we also try to pick p negative z y. Okay, so here we have f of negative z square plus y plus f of y equals f of negative z square and then plus alpha y. Okay, so we notice that z square and negative z square are the same thing, which means that on the left side two expressions are the same, which means that the right expression are also the same thing. And in such a way, alpha y and alpha y can be cancelled, and actually f of z is 0. So which means that we have f of negative z quantity square to be 0, which means f of negative z is also 0. Okay, so f of z is 0, f of negative z is 0. So here let us try to pick P0z. Okay, so here we have a f of 0 square is 0 plus z plus f of z, okay, equals f of 0 quantity square plus alpha z. Okay, and then also we try to pick P0 negative z. In such a way, we have f of 0 square is 0, and then minus z plus f of negative z. Okay, equals f of 0 square minus or plus alpha times negative z, like this. Okay, so we notice that f of 0 is 0, so 0 plus z is z, f of z is 0, so the whole thing is 0. Similarly, f of negative z is 0, 0 minus z, this is negative z, f of negative z is also 0. Okay, with these two joint equation, we can have f of 0 quantity square is 0, and also alpha z is 0. And we notice that alpha is not equal to 0, which means that z equals 0. Also, we have f of 0 is 0. Okay, so it really implies that f of 0 equals 0 and f of x is not equal to 0 if x is not equal to 0, because we suppose f of z equals 0, and finally we find that z is equal to 0. So which means for all other value of x, f of x won't be 0. Okay, so this is a important result up till now. Okay, so next we try to pick p of x comma 0. So in such a way, we have f of x squared plus 0 is nothing, and then plus f of 0 is also nothing. So on the left side is f of x squared, and on the right side we have f of x quantity squared plus alpha times 0. Okay, so here we have this important equation. Let's call it equation 1, and then we can have for all value of y which is greater than 0, and we can define it to be x squared, so that here x is not equal to 0. In such a way, f of y is equal to f of x squared, which is f of x quantity squared, and this value must be larger than 0, because x is not 0, so f of x is not 0 either. So f of y, so here we have f of y is strictly greater than 0 if y is greater than 0. Okay, so next we can have p of 1 comma 0. So it will be f of 1 square is 1 plus 0 plus f of 0. So will be nothing. So on the left side is f of 1 equals f of 1 quantity square plus alpha times 0 is 0. So here it implies that f of 1 is equal to 0 or 1. Okay, so there will be two subcases. So let's consider case 2a, okay, which is f of 1 is equal to 0. So here we try to pick p0 comma 1. So it becomes f of 0 squared is 0 plus 1 plus f of 1 equals f of 0. F of 0 square is 0, and then plus alpha times 1, which is alpha. Okay, so here we have f of 1 to be 0, and then 1 plus 0 will be 1. F of 1 is also 0. Okay, so which means that alpha equals 0, but it contradicts with our assumption here, alpha not to be 0. So which means that this is a contradiction. So for case 2b, we have f of 1 equals 1. In such a way, we have p of x comma 1, which is f of x squared plus 1 plus f of 1 equals f of x quantity square, which is f of x squared according to equation 1. And then we can have a plus alpha times 1, which is alpha. Okay, so it is actually, this is f of 1 is 1, so this is f of x squared plus 2 equals f of x squared plus alpha. Okay, let's call it equation 2. And in equation 2, we try to pick x to be 0. Okay, so we will have f of x squared is 0, 0 squared is 0, plus 2 is 2, equals f of 0 plus alpha. Okay, f of 0 is 0, so this is alpha. And then also we try to pick x to be square root of 2. So we will have f of square root of 2 squared is 2, 2 plus 2 is 4. So equals f of 2 plus alpha. And then f of 2 is alpha, so this is alpha plus alpha, which is 2 alpha. Okay, also we try to make use of equation 1, which, and substituting x by 2, so we have f of 4 equals f of 2 quantity squared. So substituting f of 4 to be 2 alpha and f of 2 to be alpha, we have 2 alpha equals alpha squared. Okay, so it implies that alpha to be 0 or alpha to be 2. Okay, similarly, for this case 2, alpha is not equal to 0. So we would like to reject alpha to be 0. So we have alpha to be 2. So okay, so here let's try to plug in 2 to the original function equation. Becomes pxy, which is f of x squared plus y plus f of y equals f of x quantity squared plus 2y. Here let's try to pick p0 comma y. Okay, in such a way we have f of y plus f of y equals 2y. Okay, so here let's try to define a function g, which is from real number to real number, such that g of x is actually f of x plus x. Okay. Or we can write it as f of x is g of x minus x. Okay, so here from this one we have a 2y equals f of y plus f of y. Okay, so looking at this one, okay, we can actually making it to be f of g of y, okay, so this is g of y. Okay, so and making use of this expression, f of something will be g of this something minus this something, okay, which is g of y minus g of y. Okay, like this. Okay, so in this case we have g of y minus g of y minus 2y to be 0. Or maybe we can just replace y by x, which means we have g of x minus g of x minus 2x equals 0 for all x are real number. Here we can also define a0 to be x, and then an plus 1 equals f of an. So in such a way, from this one and this definition, we will have an plus 2 minus an plus 1 minus an to be 0. Sorry, 2, okay, because we have a 2 here. So to solve this difference equation, we can writing out the characteristic equation, which is a z squared minus z minus 2 equals 0. It implies z minus 2 times z plus 1 equals 0. Okay, so in such a way, we have a z equals 2 or z equals negative 1. Okay, so what does this 2 and negative 1 means? It means that g of x equals 2x and g of x equals negative x is a solution to this to this functional equation. Okay, but actually for this expression and then making use of this definition, we will have f of x equals g of x minus x, so which means that g of x f of x equals x and f of x equals negative 2x. However, we can simply check that this is a solution while this one is not a solution. This is okay, this is not, which means that when alpha equals 2, there is only a single solution, which is f of x equals x. So which means that alpha equals 2 is the only solution. And this is the end of this video.